if I say to you, are these two fractions equivalent? Like 1/2 and 3/6. Are those two fractions equivalent? How do you know that? They both equal 1/2. How do you know that 3/6 equals 1/2? You simplified it, right? So shouldn't 1/2 and 3/6 have all the same properties all the time? Yes, right? What happens if there's a variable involved? What happens if it's more like these two equations that you can't see right now? If it's these two equations. First of all, we need to prove that they are equivalent, yes? How would I prove these two fractions are equivalent? I could plug something in for x. That's a really good way to do it. Could I also simplify this fraction like you were talking about the 3/6? I could simplify it. How can I simplify a fraction with variables in it? It starts with an F and it's not the bad one. Factor. Okay, I could factor it, right? In fact, that's what it asked me to do on number 1. It says show that the two functions above are equivalent by factoring and simplifying y sub 2. So if I have x over x squared plus 2x, how would I simplify that? Well, you said factoring, right? Can I factor the numerator? No, it's just an x, right? Can I factor the denominator? Yes, because both terms have an x, right? So I could factor out an x. But can I go back for just a second real quick? Can I factor this one? Because they both have an x, can I just cross out these two x's? No. If you can, if you think you can factor this way, I need you to understand you can also factor this fraction by crossing out the ones. And by crossing out this line over here, so that your answer is this. That's ridiculous. Except, it's that same thing if you're trying to cross out these x's. It's ridiculous. This one's easy to see that it's ridiculous, right? But if you're trying to do that, you're also trying to just cancel out the x's. This is what it's looking like to a math person. So don't do this. That's ridiculous. Okay? Factor out an x in the denominator of this fraction. What do we have left over? X plus 2. That's exactly right. Now, can I simplify? What can I simplify first? Tell me that. Now, why can I simplify these two x's right now when I couldn't do it before? It's not attached to anything, right? This is being multiplied by this term, which means these two things are factors. I can simplify factors. I can't simplify parts like here. Okay? So I can simplify those two x's. What is x divided by x? 1. So this is a 1 and this is a 1. So what's left when I simplify an x? X plus 2 is what's left? You sure? Oh, 1 over x plus 2, right? Because x plus 2 is in the denominator, isn't it? So have we proved that y2 is equivalent to y1? Yes. So let's look at the tables of y1 and y2. So in your calculator, which you all got when you came in, right? Or pulled out of your bag, let's generate tables. Let's figure out what these values are. Let's start at Blaze's. Let's start at your table. You tell me the first term in y1. No, I'm being patient so you can have a chance to put it in your calculator. It's fine. I'm not saying, tell me right now! Because that would be weird. And probably rude, but whatever. Undefined, okay. Next to you, -1. 1. Across? Either one of you, it doesn't matter. Okay. 0.5, okay. What you got? She's helping her out. Do you have it? 1/3? And somebody else at your table? 0.25. All right, keep going at your table for y2. Do you guys have y2 in yet? Okay, they're helping. Does anybody else have y2? Undefined is for -2. What about -1? 1. All right, what about for 0? Uh-oh. Is that right? Okay, well, we're going to write it down because that's what we got, right? What about 1? 1/3. And 2? 0.25. What way are the tables not equivalent? So at x equals 0, when x equals 0, the y's are different, right? Does that make you squirm a little bit? We just talked about they should be equivalent, right? They should be the same. They're not. Sketch the graph of y sub 2 below. Mine looks something like this. Mine looks something like this. Does yours look like that? Yes? How many vertical asymptotes does y sub 2 have? Look at it. How many vertical asymptotes does it have? It has one vertical asymptote. Does this match the information in the table? How do we know where vertical asymptotes are by looking at our table? Undefined. How many vertical asymptotes should I have according to our table? 2. How many do I have? Then does it match the information in the table? No. So that's weird. So we're going to pause that example for a second and go to this one. Well, we're not really pausing it because we're not going to go back to it. We just know that it's weird. Okay? Look at this one. Y equals x squared minus 3x over 2x minus 6. Find the vertical asymptotes. How do you find vertical asymptotes? Okay, so there's 2 ways you could know. First of all, we worked on this yesterday quite a bit. You know you just set the denominator equal to 0. The other way is that it literally says right there. Right? So 2x minus 6 equals 0. Add 6 to both sides. 2x equals 6. Divide both sides by 2. X equals 3. So in this problem, we think there's a vertical asymptote at x equals 3 because we set the denominator equal to 0, right? So generate a table for this function. Several of you haven't had a chance to contribute to our conversation yet. So if you haven't had a chance to contribute, be ready to tell me one of these values for the table. I'll give you a minute to put it in. That's fine. When somebody knows what y is when x is 0, let me know. What? 0? Does anybody know about 1? 0.5? What about when x is 2? What's y? 1. And then 3? Undefined. And then 4? 2. Does the table support the location of the vertical asymptote found in number 4? Yes, and why? Why does it support that? It's undefined when x equals 3. Yes. That's what my graph looks like too, Blaze. What's strange about it? It's a line. And it doesn't have an asymptote. more specifically even a vertical asymptote, right? Because that's kind of what we've been talking about. Again, we get to the end of the column, which is the end of the problem, and we think, that's weird. Okay? Usually values of x that make the denominator equal to 0 will create what? What did we talk about all day yesterday? Okay. Or not plural, but at least one vertical asymptote, right? Unless that makes the, use your context clues and see if you can figure out what goes there. What'd you say? Nothing? Close. The numerator. Listen, usually values of x that make the denominator equal 0 will create a vertical asymptote unless that value makes the numerator equal to 0 also. If it makes the denominator equal to 0, we talked that it's a vertical asymptote. But what happens if it also makes the numerator equal to 0? Removable discontinuity. That's a removable discontinuity or a hole in the graph. Okay? So if this is the problem that we're given right here, first of all, we factor it. We talked about factoring already, yes? We factor it. If there's a factor in the numerator and the denominator that is exactly the same, that's going to give you a hole, a removable discontinuity. So you have to factor it and look, do they have a common factor in the numerator and denominator? If they do, that's a removable discontinuity. That's a hole. If you have a factor in the denominator that also doesn't have a factor in the numerator, that's still just exactly the same thing that we did yesterday. That's still a vertical asymptote. Does that make sense? Well, if it doesn't now, it will in a minute. Okay? So if you plug in an x value and get some number over 0, like in a fraction, a number over 0, that will be a vertical asymptote. But if you plug in an x and get 0 over 0, then removable. Then you'll have a removable discontinuity. Yes, ma'am. But here's the deal, guys. The table is going to say error or undefined either way. The only way that you're going to know for sure is to factor. Got to factor. Remember I told you when we were factoring we're going to use this for the rest of the year? It's still the rest of the year. Okay? So here's your 6 homework problems. Okay? I will do one of them for you in the top row. Which one do you choose? 2? Everybody okay with 2? All right. So, do you remember what these all stand for? You got it okay? All right. So, what do you want to do first? So what's funny is that most people in earlier classes want to do the horizontal asymptote first because it requires no math, really. You're like thinking, right? How do we find the horizontal asymptote again? Exponents, right? The degrees. Well, in the numerator, the degree is 2, and the denominator, the degree is 2. So what do I look at? I look at the leading coefficients right here. What's there? 1 over 1. So where is the horizontal asymptote? Y equals 1. I know that you think I'm picking on you by making you write y equals 1. I don't care. Really, the asymptote, it's at y equals 1. It's not a 1. 1's a number. Y equals 1 is the equation of a line. And even though that line doesn't really exist, we still have to write it as a line. Okay? Now, after we find, and you don't have to find the horizontal asymptote first. I was just explaining why the others wanted to find it first. Does that make sense? You can find it in whatever order you want. Okay? But what do we do now if we're trying to find vertical asymptotes and removable discontinuities? See, I knew I'd mess it up. We need to factor. Okay? So factor the numerator. What multiplies to be negative 8 and adds to be positive 7? Negative 1, positive 8. Everybody okay with that? Now factor the denominator. What multiplies to be positive 4 and adds to be negative 5? It has to multiply to be 4. It has to multiply to be 4. Negative 1 and negative 4, right? X minus 1, x minus 4. What do you notice right here? It's a common factor in the numerator and the denominator. What does that tell you? It tells you the whole. It tells you the removable discontinuity. Set it equal to 0 and solve. X equals 1. What's left in the denominator that we didn't find a factor of in the numerator? Then what does that tell us? That's the vertical asymptote. Set it equal to 0. What do you get? X equals 4. So, before I let you go, I want to ask you a question that has been asked to me several times today, and it's a good question. Okay? What do we do with that? Nothing. We don't care about it. I mean, I'm sure it's a nice factor, right? We just don't care about it. The only time we care about stuff in the numerator is if it's also in the denominator. When it's also in the denominator, that's our removable discontinuities. Otherwise, it's just a nice factor that we have. Okay? So, again, before I let you go, let me make sure that you understand. Do you have to have a horizontal asymptote? Or are you allowed to write none? You are, right? When are you going to write none? When the degree of the numerator is greater than the degree of the denominator. You remember that? Are you allowed to write none on removable discontinuities? Will you ever have a time where there's not any factors in the denominator? Yes, ma'am.
Do you have Gracie found you?
Yes, I do.
Can you send her to the office? She's leaving.
Yes, I will.
Thank you.
Yes, ma'am. Gracie, you need to go to the office. You're leaving. I didn't know if you heard. Will you ever have a time where there's not any factors in the denominator that are also in the numerator? Isn't it possible? Isn't it possible that you won't have any common factors? So that might there be a time where we write none for removable discontinuities? Will we ever write none for vertical asymptotes? Will there ever not be a denominator if we're talking about rational functions? No. So if we're talking about horizontal asymptotes, we're allowed to not have one. If we're talking about vertical asymptotes, we'll always have one when we're talking about rational functions. But we might not have any removable discontinuities. Okay? Here's the thing about if we had no removable discontinuities and it was a problem like this, how many vertical asymptotes would I have? Like this was a 2 instead, so that I didn't have any common factors. How many vertical asymptotes would I have? I would have 2, right? Because both of these are factors in the denominator, and if they don't have anything in common in the numerator, I still have to set them both equal to 0, and they're both going to be vertical asymptotes. So if I have none written for removable discontinuities, chances are I'll have more than one vertical asymptote. Okay? I may not, but, there's that. Questions? All right, Marcus, I go.